Hello folks, I thought we'd get through another really nice radio. No doubt dropping all my things on top of the microphones. Bought this off another dealer and it's a fully done set, so I can't sell it on without checking it myself, just in case something has got overlooked or is a miss or whatever, but it's going to be a spot on set. And you know, we did that Fidelity 2001 last, and it was a lovely set. The sensitivity, absolutely brilliant. So we're going to have another lovely set. Mind you, you need an electron microscope to read the meter on one of these. Cybernet 134. It's the lower end version of the chassis, of course, because it's only a 2-knob set. Having said that, of course, there's a rider to that, and that's the SMC Oscar 1, which is the high-end chassis with only 2 knobs and a tiny meter. So, I don't know, we're probably about the 27th today. It really doesn't matter. No, I think it's the 26th. Let's go for 26. Binatone Speedway 11005369. So I'm looking forward to doing this. There's some sets I look forward to, some I don't. Interesting comment which you won't have seen because it ended up in the filter. And you know what? I've got a lot of filter set up on YouTube. Is to stop really, really bad things or people putting illegal comments. You know, with I've got a YouTube channel with me playing hymns on the pipe organ. What is it? UK Hymns or something like that. Pipe Organ Hymns UK, I think it is. And instead of doing this, you should be spending time with prostitutes. Yeah, they're the kind of comments which I don't want. And so, we've got to get rid of the black, those screws and put black ones in. I haven't got a power plug on here. We have them new. Does that mean I'm going to have to take one out of stock to do a test? No, we'll jam the crocodile clips in. I've taken the screws out of this a few weeks ago. I needed to look at something on another Cybernet set we'd got in. So I thought, I know what we'll do. We'll check that Binatone. Oh yeah, this comment. I'm doing the deviation all wrong, it turns out. Right, well, so here's the thing. We have a deviation meter on the test set behind me. We have a deviation meter, let's put picture in picture on, plugged in, which is part of this Marconi test set. This is a Marconi 2951, is it, or 52? 2951. There's loads of versions of these. This is the latest one they ever did. I don't know if I can zoom out. I've shown this. I've shown the other. I've shown all the test sets. We might be able to do it this way. So we've got all these cameras set up on this test set, so we don't have to have you looking at it from a million miles. There's supposed to be an insert there. The only thing that doesn't work properly on this is the deviation meter. And when I know it's not right, it's just capacitors, but I'm too near retirement age to strip that down and do the capacitors. We've got either 3 or 4 of these test sets. We've currently dismantled quite a few of the benches, and we've only got 3 benches in operation. We've got this bench, the one behind me, which has got the Quartz Lock 282A test set on it. Now, that test set doesn't go under 88 megs, and of course we're using it solely for business radio, which is going to be either VHF high band around 168, 170 megs, or if it's on UHF, it's going to be 460 odd megs. Unless it's on a repeater, and then it's 427 transmit, 441-ish receive. So you've kind of got ham band 77s in between. So that's what we do on that bench. I've shown you that bench several times because we've got a sweep generator on there, and before I started using the SINAD method for fidelity thousands, I was using the manual shown sweep generator method, which is cumbersome and doesn't actually get you better results. So you think, well, why don't you do it as the manual says? Well, because test instruments have improved over the last period of time, the last 40 years. This Marconi test set is 1982. And, you know, they're like £5,999. We've got either 3 or 4 of these, can't remember. And that's the one that happens to be on this bench. And it's not getting moved, it's not getting replaced. That's it. So here you go. There's a built-in deviation meter in that multifunction meter. We can do AM modulation, which is working fine. We can do FM deviation, which, because of capacitors, sometimes it works, sometimes it doesn't. But I know when it's not working. We just switch to the one behind, but you don't see that. I've also got standalone deviation meter. And we've also got a Schlumberger Stabiloc 4040 test set, which we're not using, and we've got Farnell SSG 520, TTS 520 combo test sets with 2 of those, and we've got a transportable version of the Farnell as well. So there you go. But the Farnell ones have got a digital meter for SINAD, and I find that harder to work than the analog meter that we're using, the Motorola SINAD meter that I do. This has a built-in SINAD meter, but I say with 3 or 4 of these test sets, and either none of them work, or you've got to connect something up which I don't know about. I've got the instruction book, I don't know. So there you go. I've never figured out the SINAD meter on those. It's like the IF probe. There's obviously some optional thing you could buy at the time, but there you go. I've never bought one. So this person put the comment, "You're doing the deviation setting all wrong." Well, we do this to the service manuals. Now, not all of the radios have service manuals, of course. So then we'll revert to a service manual. And for example, here's a realistic service manual. These are superb for the realistic 1005. And so the first thing it tells you is, well, it isn't the first thing it tells you. It's well down the list, isn't it? Have I not scanned the page which tells you what test equipment to use? Here I am trying to do a show and tell. No, it doesn't, does it? Why is that? Okay, well, all the realistic service manuals, it tells you what you need. Oscilloscope, AC vacuum tube voltmeter. Well, it's FET voltmeter, isn't it, these days? DC vacuum tube voltmeter. Frequency counter, 8 ohm dummy load, RF signal generator covering 455 kHz and 30 megs. We also found 10.695 handy. A power meter, a 50 ohm dummy load, an audio signal generator, a distortion meter, DC power supply, 12.5 volts, 2 amps. For this radio, because it's not 13.8 volts, a DC current meter, a deviation meter. So here we go. Oscilloscope, I've got 2 in front of me. AC VTVM and DC one. We use the digital meter, but if I need an actual physical meter that moves, I've either got a homebrew one, or we've got a well, Tandy's sold it under our Archer brand. These aren't for accuracy; these are for finding a maximum peak. Then so I don't use. Oh, he's only using a £59 meter. He's not using a fluke. Because it's not for that. Frequency counter, got one built into there, and that is locked onto. It's using a satellite, producing the reference. all the test equipment are connected to that. RF signal generator, well, of course we're doing this 27 megs frequency, we're doing 455 on the other one I show you, and we're doing 10.695 on the other little one I show you. Power meter at 50 ohms is built into here, it's in ranges, and it's selective. So like with a bird through line, where it has different inserts to give it different frequency ranges and different power ranges, it only reads within the ranges you've set it to. So whereas on a hobby power meter, you put the output of a radio into it through a dummy load, and it's going to say, you know, it's 4 watts or whatever. We can't really tell on a hobby meter what watts are on the fundamental frequency and what aren't. Whereas on this one, you're going to get nearly all of it on the fundamental frequency you want. So all our power readings are going to be less on this, but the truth, than they are on a hobby type meter. So it's like using a bird through line. A 50 ohm 5 watt dummy load is built into the test set. Now because it's for business radio, it's a 30 watt test set, and because in the UK business radio's maximum power is going to be 25 watts. Audio signal generator, of course, is built into this. Distortion meter is, of course, built into this. I'm using external power supply, which is 2.5 amps variable, and the current meter, deviation meter, is built into that. But I say the things are capacitors need changing out, so I use the machine behind me. Now, so if you're doing it the wrong way, so in the UK, citizens band radio deviation needs to be between 2.2 and 2.5. They want you to set it for 1.5, and so it would be very, very quiet. So then you just get the setback because it'd be too quiet. So if you go over 2.5, certainly if you go over 2.7, you're going to start causing bleed over. So we had that yesterday, that set for 2001, with it doing 30 kilohertz deviation. You know, transmit on about 5 channels at once there. They only sound louder to a Fidelity 1000. All you get on is a loud that's all you get. So what they want you to do is they want you to connect to your signal generator, your audio signal generator. Industry standard is a 1 kilohertz signal, and it's 2 millivolts. So they want you to put 2 millivolts into the mic socket and then adjust the deviation for 1.5. Now we don't do that. If we were at a factory and we'd got a line of 1,000 of these sets to do, of course that's what you do. You have set up a dummy mic plug with a PTT switch somewhere. You connect to your signal generator, you put in the 1 kilohertz tone, you put it in at 2 millivolts, and you adjust for, well, it's going to be a bit more than that. But we don't do that because we're using the microphone on the set. When I did the Pi training, you were issued a little tiny loudspeaker like this, and that was connected to a signal generator, and then you held it up to the mic, and that's how they expected you to do it. Nottingham Radio, he didn't like us doing that because it just made a racket if you've got 3-4 workbenches all doing that all day. So it was just a quick wallow on that thing. So that's the two methods. So we are going to do it into the microphone for 2.2 to 2.5. The manufacturer is going to say put it in at the mic plug, and it's the same result. But this works great if you've got a whole production line of sets to do. It doesn't work great if you're doing individual sets. You do one a day like we do. So that's an explanation, hopefully, and I'm going to leave the camera like that so you can see what buttons I'm pressing. You won't see any detail because it's going to be tiny picture in picture. But there you are. If somebody wants me to show the test set, I'll show the test set. Right, so take the lids off that. I'll just connect power somehow. Don't really want to walk across and get the power lead in the rain. 13.8 volts. The set's come on. It's on channel 36. We'll put it on channel 20, centre of the band, and oh, it's 5-pinned in, isn't it? Right. Now, here's another thing. If you go on eBay or a vendor of like Moonraker or Thunderpole and get a mic which is 5-pinned in, it's going to be for a Maxcom 4E or something which that chassis is in, like a Cobra 21XFM or a Colt 295 or something like that. It isn't going to work with a Cybernet set. So for that, you need to actually custom wire one. Here's one we prepared earlier, labelled as Sapphire. So it fits the Sapphire, it fits this Binatone Speedway, it fits the SMC Oscar 1 and other Cybernet 5-pinned in sets. The worst thing which really hurts me is when you come up to a set like this and somebody's changed it for a 4-pinned in. Sorry, someone's changed it for a 4-pin locking like you get on most radios. This isn't some dodgy standard. And the other one, which is 5-pinned in, is realistic, and that's a different wiring once again. So this mic will be the right mic. Standard replacement mic. We will plug in our... I'm going to use the PA speaker at this stage because we're not doing the SINAD at this moment. These sets don't have PA. There we are, sat there hissing away beautifully. Test set's been on about an hour and a half, so whatever this is going to be accurate. We need to start off by doing the VCO. You haven't got the strapping wire on this one. They must have been too cheap to put in that 1.5 inch of wire. So on receive we should have 4 volts. We've got 4.17, and on transmit I'll just key it up. We've got 5.58. I'd like to adjust that. So it's a bit too high. High doesn't make it better. High means it could go out of lock on some channels. I think we've got a set coming in for repair, which is a new in a box Rotel 220, so it's the same chassis as this, and it doesn't work on channels above 28 or something like that, and that's exactly what this is. This is exactly the problem you get. So, firing the resistor 4, going to transmit, adjust the trimmer and hope some manufacturer hasn't got wax in it. I've bought a video recorder on eBay. It's at Lincoln, 28 miles away. I would have done a road trip, but they can't do with us till 6 o'clock, so it'll be dark by then. Right, so that's done the VCO. So I am glad I'm checked it. So I'm not saying he did it wrongly, but something's changed between when he did it and now I've got it. 5.1 wasn't it? So let's look at the frequency. I'm not going to change cameras now we've got this. This has been requested. So on this occasion we're going to leave the test set there, and you won't be able to see, but it's 27. Oh, it's on channel 40, of course. Oh, we're supposed to double check this on channel 1. I'm kind of not there, am I? I'm telling you so many stories this morning, this afternoon, whenever that. So on channel 1, it's supposed to be 1.8 to 2.3, 2.27 on receive, and 2.38. I think it's up to 2.4 on transmit. I don't need to dig the service manual out. we always use the Rotel 240 manual for all the Cybernet 134 sets, apart from the Midland 76900 base station, because we've got the exact manual for that as well. So there aren't many radios had a proper service manual. The Fidelity 2000 would have had, but we haven't got it. The Rotels had service manuals for all the 3 models, and I had a friend who I lent 2 of those manuals to, and unfortunately suffered a brain hemorrhage, and I'm not going to start, asking his wife to go through his things looking for it. Right, so go back to channel 20. Let's see if it's on frequency, and it should be 2779125. It's 119. It's all neither here nor there. They drop with age, so we'll leave it there. So it was 2779119. Now 2779126. Obviously it should be 79125. Deviation into this test set as it hits the microphone with the clipboard should be 2.2 to 2.5. Wow, it's reading 2.15. That might be accurate. I'll put it there because on this test set I don't know. Look at the power. So on the 3 watt scale, when I transmit, full scale deflection is 3 watts, so it should hit the end stop. It does. So we'll go to the 30 watt scale. So 30 watts full scale deflection, 4 watts is there. And it's 3.9 watts. So, that's brilliant. 3.9 watts. 3.8 watts on channel 40. And 3.9 watts on channel 1. I could say 3.85. That would be probably a bit nearer. Channel 20. Not 2.7 watts like you get out of the new sets. So, low power, doing 300 milliwatts, and this isn't a legal requirement anymore, as you realise that was for when, if you had a base station area higher than 7 meters from local ground level, you had to drop your signal to 0.4 of a watt. Don't know how many people did, but that was the rule. Right, it is a useful feature though. You're in a convoy and you're chatting to your mates, you're not blowing each other's windows out, and if you want low range around a farmyard, it's great. So, current consumption 1.019, that's really good. Right, we'll just go through the transmitter. I say the person who did this before knows what they're doing. So we're looking for the centre of the peak, not just the peak. So we've got the maximum chance of having it pretty accurately the same on the 40 channels. And this isn't far out at all. And that might be the best we can get. It is supposed to be between around 0.1 maximum difference between the channels, which is exactly what we've got, 3.85 to 3.9. So we've got to temporarily peak these to absolute maximum power. Sometimes you come across sets which have been left like this because some wally thinks you're tweaking it up. They're not going to get better range, they're going to ruin the set, and of course that would be illegal anyway, but legality aside, you are not going to get better range by making one of these do 4.5 watts instead of 4. The manufacturer says that it's set to be set to 3.8. but then they've got to get through. They've got to get them through customs, and we haven't. Because when they're batch tested by the government, if one set is overpowered, they're going to probably pull 2 samples out of a box of 1,000, and if anything is wrong, the whole batch will be rejected. So I've got just about 5 watts there, so we need to take the yellow one clockwise to 4.4 watts. We want to take the green one anti-clockwise. The manufacturer says to 3.8, but we're going to have every ounce you're allowed, which is 4, and that's there. So let's see where we are now. So on channel 20, it's 4 watts. On channel 1, it's 4 watts. And on channel 40, it's like 4.02. So it's 4 watts. So I've managed to get that more accurately. So I'm not saying he was wrong at all. This was done a few years ago, and it's been shipped to me from Stockport. So that's that bit done. The meter, which none of us will be able to see. If I put about 3 pairs of glasses on, I might manage it. When we key up, it's supposed to be on 4. And because I don't know whether that's hitting the end stop or not, we will just readjust it. Well, that is 4. So it was spot on where it was. Because where 4 is and where the end stop are is pretty much the same. Meter lamp's working. Switches are working. Potentiometer's working. Socket's working. It doesn't have that. So I'm going to do receive before doing deviation, because we need to go through the test set. So on receive, you haven't got the extra circuit on this lower chassis. This doesn't make this less range. It means that there's a possibility, if you're in a large usage area in a big city, that you could get more bleed over from other users. It's just about the selectivity, it's not about the sensitivity. So there's no range difference. Right, I'll switch my SINAD meter on. We'll make sure we've got 2779125 on the signal generator. There's the signal generator. This is the deviation and modulation meter frequency, which is set. I don't need to adjust that. This is the AF generator, set for 1 kilohertz. And we can set it to any frequency we want, because when we're doing business radios, we're going to need to apply a CTCSS tone. That's for continuous coded tone Squelch system, which keeps the radios quiet until the firm they're using them with is given the same lock code by the government on their license. Doesn't give them a private channel. Motorola call it private line. No, it's not. What a load of. Yeah, right. 2779125 on the signal generator. And we know we're on frequency on the radio, so there we go. 2779125 on the signal generator. Turn the volume up. We'll plug in instead of the speaker on the wall, we'll plug in the one that goes to the test instruments. Just needed an earth on that. Right, so let's see what we've got. So as we know, these are capable of good results. You can end up with 0.2 microvolts. but the manufacturer says anything better than 0.7. So I'm now going to have to switch from this test set. So we've done showing you this test set. This is the attenuator. So as I turn this up and down and turn the volume up so you can hear what we're doing, we get a stronger signal. I have to constantly be changing this when we're doing the tuning. In fact, no, I'll tell you what, we'll forego you seeing the SINAD meter so that we stay with this view. Meter says it wants to be switched off, so. Right, what have we got? So, I've set my SINAD meter so the needle's on 12 for 12 dB. I'm on the 1 scale, and we're at 0.2. There's 3. There's 2. 2, 4. It's 0.27 microvolts. Really good. Now for 10 dB, so we'll just turn it down so my needle's on 10 on the SINAD meter. We're now at 2.2, 0.22 microvolts. And then for 20, not all radios will do 20, but Cybernet will do, is 0.71. This doesn't matter that much, it's just how much noise there is in the signal. So while we're at it, we'll do the squelch. So I'm going to turn the squelch to full on the radio. I've now got full squelch. Then we're going to turn this attenuator. I want it to open at 100 microvolts. There isn't a hard and fast rule on this, but that's where I want it to be. There's no point having a squelch. So when you've got it set to full, it never ever opens. And we get some sets like that. Ooh, our squelch is so strong, nobody can break through it. 3, 10, 30, 100. Spot on. Now we'll do the opposite. We'll turn that to 0.3 of a microvolt, and we'll park it and turn the signal generator to standby. I've now got a red LED lit up to tell me the signal generator is on standby. Now on the radio I'm going to turn the squelch down and set threshold. Switch the signal generator on. Remember it's parked at 0.3 of a microvolt. Just came in for a second. So it's coming in between 0.8 and 0.9. So it's 0.85 microvolts, the threshold. Excellent. So now let's have a look where the meter is. So the industry standard for the UK for an FM CB radio, not for an amateur radio, is 100 microvolts. But we can't see this meter, can we? And what does it actually say? It's actually a bit low. It's it wants 3 millivolts to read S9. So that's something that's gone out. So we'll just go through the receiver. So turn the squelch down. I want on the SINAD meter there to be about 6 dB. So we'll turn the attenuator down, which I now have done. I've now only got 0.19 microvolts on the signal generator. That's what you're hearing. The SINAD meter is reading 6 dB, and I want to improve that signal by adjusting the front end. That was spot on. We might have gained a fraction there. I'm going to now, because we've gained the fraction, need to turn down the attenuator so my SINAD meter's back at 6. Because you mustn't saturate it. There we go. Then we're going to do the IFs. Need a bit more signal for that. So I'm satisfied the IF's now right. Let's do the S meter while we're at it. 100 microvolts on the signal generator. We can turn the volume down so as not to annoy people. And there's S9 on the meter, which none of us can read. I'm just going to jump back to transmit because I forgot to do low power. So it's low power to switch at the back on these radios. That's now 400 milliwatts, which is there. 3 watts is there. 400 milliwatts is there. We're on the low scale. We go back to the high scale, and we're still doing 4 watts. Right, so now we will read what our receive has got to say for itself. Just like I did before. Turn my... Oh, I haven't done the detector because I normally show the oscilloscope and haven't done. I bet it's spot on, but I've got to tell. So we're still at 100 microvolts. I'm looking for the maximum recovered waveform on the signal on the oscilloscope. It's spot on. Glad about that. So for 12 dB SINAD, I've got it lined up on the 12 dB. I'm on the wrong scale. I need to be back to the 1 scale. It's 0.22 now. So we have gained. And for 10 dB, it's just under 0.2. If I change scales, there's a bit of overlap and it'll give me the same figure, so I may as well, I know that unless it's significantly better than 0.2, not to bother changing scales. And for 20 dB, we've now got 0.43. So I've managed to get another 10 yards range out of it. That might have affected the squelch. So, squelch to full. Attenuator 1, 3, 10, 30. It's coming in at 30 now, which is too early. So, I'll turn the preset till it disappears. So there we are, the squelch has come in. Now when I turn my attenuator to 100, the squelch opens, so that's set back right. So now we're going to do the opposite, park it back to 0.3 microvolts, put the signal generator to standby, set threshold on the radio, switch the signal generator back on. That was an error, I put it into the wrong mode. I've got ×1 and ×10, so it puts a ×10 signal in just then. So we'll just do that again to ×1. Let's see where it is. It's now 0.62. So squelch sensitivity is picked up as well. Not that there was anything wrong with that. We've done the S meter, that's now set to 100 microvolts. We've set that to 400 milliwatts. And we need, well, I'll just tell you what the transmit current consumption is. I'll just unplug the speaker so we don't get some kind of feedback. It's 1.13. A little bit more current for a little bit more power. So that's it. We are done. And that is a lovely radio. I bought our original sample. I can't remember whether I got it from Wigfalls, the Sheffield-based firm long gone, or whether I got it from Rumbelows. When I bought it for just $29.99 in a clearance sale, the deal was that the meter plastic was broken. So our original sample had a meter plastic broken. So, is that the right lid? I've lost the lid already. got there? I've run out of black screws. I've got some on order. Put the tags back on. It's yellow to the right, isn't it? That's the positive. There we go. Speaker works. I'll just put one wrong screw back, just says he falling over, just to hold it together. I don't even know where the screwdriver's gone. There we go. Fingers has got it there. Oh, we've got deviation to do, haven't we? See, I'm not doing this in my normal way. So, read about right. I'm going to disconnect it from this test set. There's no point now having picture-in-picture on because I'm not on this test set anymore. And we'll go to the test set behind me. Just to verify where the deviation is. Wall. Actually, it's very slightly high. It's 2.7. So we want this preset to be in the centre, which it is. In the European version, you don't get this vertical preset. It's a fixed resistor. So I'm not quite sure why they did this kind of. It's an automatic gain control feedback thing, but the centre position is the best position. Wow, that's it. Just pop that down a fraction. It's lucky we checked that, isn't it? Oh, it'd blow Mr. Chippie's ears out. Right, so I'll switch off the other test set. And now we'll plug it into the roof aerial, which is the Antron 99 or the Solarcon 99 or the Cadbury's 99 or whatever kind of 99 that fiberglass 18-foot aerial is. It's the one without the optional ground plane kit, mounted just above single-story building roof level into an apex concrete tiled roof. And we get good takeoff towards Nottingham, so we can kind of get 30 miles that direction, but you usually hear the burner brigade anyway. One on a Roger. A Roger. There we go. Well, we're not going to hear anybody, we don't usually, do we? Right, we'll do an on-the-air test later on with that, and that is a splendid radio which will find its way onto eBay when I get round to it. Thanks for watching the Binatone Speedway Cybernet 134 set from 1981.